The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. This is Elisa Baum. I am GridGain Systems Director of Product Marketing, and we'll begin in just a moment. First, I need to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? So I'm looking for hands. I see hands. Great. Next, during this webinar, you will be on mute. But should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. And in addition, a recording of this webinar and the slides will be made available to everyone within 48 hours. I'd like to introduce today's speaker, Dennis Magda. He is GridGain Systems Director of Product Management, and he's also the Apache Ignite PMC Chair. So I'm honored that he's here today to talk to us, and the topic is stream ingestion, processing, and analytics using in-memory computing. And with that said, I'll turn the floor over to Dennis. Go ahead, Dennis.
Yeah, thanks, Alyssa, for the introduction, and hello, everyone, and thanks for stopping by our webinar. This webinar is a continuation of our series where we were reviewing in-memory computing applicability for various use cases and scenarios. So first of all, our first part was about in-memory data grids in general. So how we can use in-memory computing platforms such as Ignite or GridGain to accelerate our existing deployments, which are basically based on relational or NoSQL databases. Then those of you who attended the second webinar had a chance to see how in-memory computing can solve hybrid transactional and analytical processing scenarios and use cases. And that during that webinar, we've demonstrated and shared the best practices on how to apply Ignite and GridGain as memory-centric database for those workloads, for those requirements of HDAP. And today we are going to finalize our series with an overview of another important topic that is becoming a hot potato nowadays. So we are going to talk about streaming. And that will be not just, a classical talk about how to stream real-time data into some storage. For sure, we will touch the topic, but the goal for today is to see how in-memory computing can be used together with prominent streaming technologies so that you can solve your real-time streaming use cases. And we are going to talk not only about ingestions or pre-processing of data that is being flushed into your storage, into your business applications, but also we are going to see and analyze something else, analytics. We want to see how we can utilize in-memory computing to analyze and get insights of that data that is being streamed in real time so that we can act accordingly. And the agenda is pretty straightforward for today. First of all, I'll try to define the goal. I'll try to define the goal for this topic, showing some, covering one of the possible business use cases for which the streaming analytics makes perfect sense and where the streaming analytics is really applied in production. And then we are going to dive into the details of in-memory computing, taking Ignite and GridGain as an example. So we are going to review Ignite native streaming APIs. Also, we are going to see how Ignite is integrated it is integrated with different streaming technologies or complements such well-known technologies such as Spark or Kafka, so that you can take Ignite, let's say Kafka, Spark, Flink, or something else, mix them together and build out your streaming architecture that can be used not only for real-time data ingestion, but also for the data analysis in real time. So let's start with the streaming analytics definition. So actually, here is I would just take this sample scenario. Let's say that we have that we are working for some major trading company. It can be Goldman Sachs, JP Morgan, all those financial institutions provide different financial instruments. When you have a trader who keeps an eye on the market data and decides which stock to buy or which one is to disregard. And actually all that trading data is being updated in real time. So every tick, like every milliseconds or throughout several microseconds, all the data is being changed and fluctuated. And a trader has to make a decision momentarily. And if to talk, and that's like an excellent example of streaming analytics. So here is we have what? We have market data that is being constantly updated, and that market data is being streamed endlessly, continuously to our system that is being used by traders. And traders have to analyze this data in real time. For sure, a trader doesn't do this on its own, on his or her own, right? Usually the application does the analysis of that data in real time. And that's like how you can use streaming analytics. The data, the market data is being streamed, and your trading application analyzes all the data in real time, providing the trader with impactful and useful insights so that he can actually earn some money. And if to talk about technical aspects, basically if we take Ignite cluster as an example here, then it can be constructed like, you can view it this way. For instance, if to assume that our trading application utilizes SQL queries, to do different aggregations of market data, to filter market data, then the architecture might look like this way. In the middle, you have your Ignite cluster, which can scale out across as many machines as you have. And then from the left, you can see that we have Ignite streamers, like something that is, the data is being streamed to Ignite in real time. That's your market data. And on the other side, to the right of the cluster, we have our client applications. Those client applications can represent your exactly the applications that are being used by traders. And the applications can run, and the application can run in real time SQL queries, do some advanced computation. It can execute probably some machine learning models, and all those executions will happen in real time over that market data that is being streamed constantly. And that's actually one of the good examples of streaming analytics. Data is being streamed constantly, and we analyze this data momentarily and act on that data. So that's like something that is being used right now in many financial institutions. But also, such use cases can be found across various industries. Let it be logistics, let it be e-commerce, or any other industry. So financial industry is probably one of the best examples. And now, like, that's the use case. Now, as an architect, as software architects, let's try to see what we can use together with Ignite to prepare a platform, a solution that will be applicable for streaming analytics. And first of all, it's straightforward to start by reviewing Ignite native APIs. So just, I do believe that those of you who have attended our calls before have seen this slide. But today, like what we are going to see, like just as a recap, right? Just as a summary, Ignite has its own memory-centric database that keeps data both in RAM and also on disk, cluster-wide. The database scales horizontally. And on top of the database, we have a variety of APIs. And today, our focus would be on streaming and how that streaming component can be utilized with various streaming technologies available in the market. For sure, for streaming analytics, we can utilize SQL, key value, computations, etc. But that's not the topic of our today conversation. That's something that we reviewed during our previous parts of this series. So, and speaking about essential building blocks of Ignite streaming capabilities, the power horse, the true power horse of Ignite streaming APIs is Ignite Data Streamer. So if you have a look at the picture on this slide, you will find the Ignite Data Streamer to the left of the cluster. And basically, the whole purpose of Ignite Data Streamer is to push or stream or flash data into the Ignite cluster the fastest way possible. So how does the streamer do this? So technically speaking, all the data that is being received by the streamer, and this data can be received over raw socket connection from some GMS queues, from other queues, from say from Kafka, from Spark, and etc., from whenever you like. And then Ignite Data Streamer takes all this data, aggregates it, splits it into the chunks of buckets, like not chunks of packets, and every individual packets with a set of different entries is being streamed to a particular node. So on this slide, we can see that we have 3 nodes, and Ignite Data Streamer locally decide which node is primary for an entry that arrived to it, and it will stream that entry to a concrete node so that you can utilize your networking and CPU resources efficiently. That's what it does. And as we learn in a couple of minutes, Ignite Data Streamer is actually being used by other integrations, like integrations with Kafka, with Spark, with Storm, or with Flame. All the streaming technologies that are integrated with Ignite rely on Ignite Data Streamer, thanks to his internal capabilities. Also, let's move to the next step. Once the data is streamed into the Ignite cluster, what we can do before we store this data into the cluster, we can do some transformations with this data. For sure, the data can be transformed or enriched before it gets to Ignite, but also you can do that last call update on Ignite side. And here we provide so-called stream receiver or transformers APIs. Why do you need to do that? Why it's not enough, to enrich or pre-process data before that? For instance, you might, if we talk about, for instance, you might want, let's say, to compare the current value with an existing one. And for instance, if the existing one doesn't have any characteristics, it will be updated, or you can disregard the value. So you might want to do some comparison of the value that is already stored on Ignite cluster side. Or you might want to do some other updates. So for instance, if that value is arrived to Ignite, Ignite might want to trigger some specific calculations. For instance, if to go back to our trading application example, when tick happens, when our market data is updated, that market data update tick will be streamed from Ignite with Ignite Data Streamer to our cluster, and then the cluster node that receives that tick, it will execute some internal calculations. For instance, it can recalculate the instrument's value, or it can do some pricing updates, or it can do whatever else is scheduled to do. And finally, final piece, also it's possible to use Ignite provides continuous queries if you want to receive updates on Ignite cluster side and you want to be notified about those updates. So continuous queries are usually executed from the other applications, and those applications who executed a continuous query will receive updates of the interest. For instance, if your some data was updated in Ignite, you can be notified about that. And finally, also we have different things or destinations. Also, if you want to do after the data was pre-processed or processed in Ignite, you did some calculations with Ignite, you can flash, let's say, final result set to something. For instance, let's take the trading application. Market data is being constantly updated. That market data update are streamed to Ignite cluster. Once the data arrives to Ignite, Ignite does some calculations, updates various parameters, and after that, it flashes this data to your trading applications. And those trading applications update your visual interface to show that the data actually was updated. And a trader can act on the new information. That's actually how you can apply those APIs. And now let's quickly, before we, the next topic is to see what else, in addition to Ignite native APIs, what else is available. So for instance, there is there are a lot of good products on the market that are used for streaming purposes, such as Kafka, such as Storm, such as Spark. And the next topic would be to see how we can utilize them together with Ignite, if you've already invested in Kafka, Spark, and etc. But before we do that, let me show you a quick example. So that demonstrates how Ignite native APIs can be used, to do some real-time streaming analytics. That would be some simple examples. So first of all, I want to start a cluster node, server node. That node will be storing our data. And here I have a simple example. So stream visitor example. So what happens here? Let me guide you through it. So we are going to have, that's like exactly something similar to the trading application use case I was talking about. We have some instruments, right? And the goal of this application is to find out the best and the most profitable instrument at a given point of time, right? So first of all, our application connects to Ignite in the client mode. That will be our client application. We create two caches, like two tables in Ignite. The first one will store information about instruments. That cache will be updated constantly. And the other cache is used for market ticks. So next, after that, what's interesting here is we are creating Ignite data streamer, that power hose, right, that we have in Ignite. So Ignite data streamer, what it's going to do, it's going to stream data into the market ticks. So actually, in reality, right now in this application, if we scroll down, we will see that all those ticks will be randomly generated. So we just going to generate 10 million updates of market data, do some fluctuations with the prices, and we are going to flush this data to the market, to our data streamer. In reality, here is instead of random generation, you might have different sources that feed you with that market data and information. So that's like the line that can be replaced in your real life application. And then what will happen on the server side? Here is this logic will be executed on the server side that is started. Where is it? Let me show window. All right, I'll start it and then I'll show. That logic will be executed on our server side. But also from this application, we are going to start a timer. And that timer is going to execute the SQL query and show us top performing financial instruments. So that's pretty simple. So let's see what's going on. So we have our server started, one server in the cluster, and one application. That's our application, financial application. So, and stream visitor. So now we see that the data is being changed. So here is in real time. We are printing out the most performing financial instruments. The data is being generated here. This logic, right? This logic, when we receive an instrument, like when we receive a market tick, we update our instrument, and we update this instrument value in our cache. This whole logic is executed here on the server side. When you start several cluster nodes, right? Then depending on the symbol value, on the key value, that tick can be processed by one or the other node. So this is how the workload, the load will be distributed. So all this stuff happens automatically. And then your application just in background retrieves and sees what the current value and what are the top performant instruments. So that's like simple application, simple example that you can play with. Here is, yes, it just complains that I stopped data streamer abruptly. So it's just a warning. So that simple application is available in Ignite standard examples. So you just need to go to streaming and to see how stream visitor example is being utilized. But it just perfectly fits our today conversation related to the streaming analytics. So that's what we can do with Ignite native APIs. But Ignite native APIs, like, they provide the basics. And as I said, like we have a lot of technologies. Sorry, a lot of technologies in the market who are focused on the streaming use cases. And that's why Ignite comes with various integrations with streaming technologies who can do a lot of streaming related activities before the data is being pushed into Ignite. And here as we are integrated, Ignite is integrated with Kafka, with Flink, with Spark, with Storm. And basically there is nothing that prevents you from adding your integration. All you need to do is what we've done for all those products listed here. You just need to take your existing preferred streaming technology into like MQTT, right, which is usually the protocol that is quite often used for the IoT use cases. And you need to integrate with Ignite Data Streamer with like that powerhouse. And after that, your data will be streamed and efficiently to Ignite. And also, like what we found, like all those streaming technologies are used quite often for initial data preprocessing enrichment before it's being pushed to Ignite. And when it comes to Ignite, after that, you utilize Ignite for streaming analytics. So the data is already distributed, and Ignite comes with APIs needed to accomplish your analytical tasks. For instance, you have SQL, you have MapReduce like Compute Grid, you have machine learning. So whatever it's needed for your analytical tasks of the real-time data can be accomplished by Ignite. Ignite knows where the data is located, and when you execute the APIs in many scenarios, the execution will take place on the same site, on the same node where the data is located. But also, like it's a crime to talk about the streaming use cases and not to mention Apache Spark. Moreover, if to consider that Apache Ignite and Apache Spark are used together, and used together not just for some random use cases, but specifically for streaming use cases when you need to do both streaming, ingestion with processing, and analytics. So let's, but before we see how both products which belong to Apache Software Foundation are used together, let's try to see what are the differences. Because like the first question which I usually hear when we talk about Ignite or Spark, people are curious, how are both technologies different? Why do I need to have Ignite if I already use Spark? And as far as I know, Spark stores data in memory. But here is like one thing that we miss at that point. Ignite first is a memory-centric database. It stores its data in its own storage. All the data is shared, meaning that if when we talk about Spark, right, Spark workers also store all the data in memory. But that data is not shared. It belongs to that Spark worker. And once usually the Spark worker completes its execution, that data will be removed and disregarded. And that data is preloaded, let's say, from flat files, from CSV files, from Amazon S3, or from Hadoop, and etc., from God knows how many different sources. So which means that before Spark can process anything, it has to preload data from somewhere. Spark doesn't go with its own storage. In Ignite is a database by definition, plus a variety of APIs built on top of that database. But Spark, yes, Spark. What's great about Spark is that Spark is optimized and used for streaming in compute engine. And what we did here is, those of you who use Spark for compute and streaming needs can use Ignite as a memory-centric storage for Spark. And the difference, like if we take if to find the difference between Hadoop as a storage for Spark and Ignite as a storage for Spark, the difference will be tremendous. First of all, Hadoop is used for big data use cases, right? When you do mostly batch processing. Ignite is used for real-time use cases, such as streaming analytics. And plus, what's more prominent is that when you, let's say, execute RDDs or data frames-based operations from Spark, in most of the scenarios, the data will not be transferred over the network from Ignite to Spark. And the question, how do we do that? So the integration between Ignite and Spark is wise enough to understand if Spark requests Ignite to complete, let's say, some RDD operation or execute a data frame-based query, then Ignite can execute the query request in place on Ignite cluster side, so that we don't need to take data needed for that query execution and bring it back to the Spark workers. But the execution takes place on Ignite side, and Spark workers receive a final result set. That's how you can reduce, that's how you can speed up your performance tremendously when you utilize both Spark and Ignite. And that's why actually when we integrated data frames SQL engine with our SQL engine, that's even how you can boost your data frames APIs. And what's also interesting about that, since for Ignite, Spark is just one more API. So the same API as SQL, as transactions, etc., etc. For Spark, Ignite is just one more storage. But the integration is so beneficial for both technologies that Spark users can connect to Ignite using our APIs. Ignite considers those Spark connections just as one extra API. All the data that is stored in Ignite can be shared among Spark workers, which is good for us. And also, most of the RDDs and data frames computations can be executed in place in Ignite, avoiding data movement over the network. And that's actually one of the reasons why Spark and Ignite are used together for both, for the different IoT use cases, for streaming analytics, and for much more. And this final picture outlines actually how this integration looks like from an architectural standpoint. So here is, let's see that somewhere in the middle, like we have Ignite nodes. These Ignite nodes can be deployed. In this slide, on this diagram, it's shown that Ignite node is deployed close to the Spark worker, but in fact, Ignite cluster can be deployed whenever you like. Let's say Ignite cluster can be deployed on AWS cloud, and Spark workers can be deployed in your own data center. Spark workers are connected to Ignite. They can share, if you use RDDs or data frames, all the data that is stored in Ignite will be shared. So basically, when you use RDDs with Ignite as a data storage, they are mutable. So whatever you change in your RDD, every RDD is mapped to Ignite cache or Ignite table. And whatever you change in your RDD will be updated in Ignite, and every change will be visible to Spark workers. And also, like the other benefits that we've already listed are in-place query execution, like SQL on top of RDDs, boosting of data frames, SQL performance, etc., etc. And before we move on with our next topic, let's take the other example. Now let's stop talking about financial industries. So we've already spent a lot of our time trying to see how streaming analytics and in-memory computing can be applied for various trading applications, which are a wonderful example of how streaming analytics is being used in practice. And now let's see what's going on in their IoT market. And so here is I created a simple demo, which is actually available on GitHub. So at the end of this webinar, each of you can go ahead and download it and run it on your own laptop. So the application is pretty simple. Again, so I'm planning to start Ignite server node. I can start as many nodes as I like. So let me start a couple of nodes here. Once the nodes are started, I'll have a cluster of 2 nodes. So let's give a little bit more time. All right. We have 2 server nodes running on my local laptop, but also I prefer to utilize for when I am developing applications, I prefer to utilize monitoring tools. So here is I'm going to use console GridGain.com, which is basically deployment of Ignite Web Console. So this console now is connected to my cluster. So that's my local cluster of 2 machines, of 2 nodes, sorry, 1 machine, but 2 processes running. And my application created 2 caches. So the first one is sensor data and temperature data. So actually the idea of this application is the following. Let's imagine that we have thousands of different temperature sensors deployed across the country, across the US. And all those sensors report and stream temperature details on what's going on in the environment. And then depending on the temperature and depending on our business use case, we can decide what to do with that information, right? Probably we just need to send out someone to the field and like if that sensor, if a sensor is deployed, let's say in a factory and the temperature goes up, meaning that there is something wrong in that factory and we need to send an engineer who will fix pipes or tubes or whatever else what's going on in that factory. And our application, what else? Here is we're going to use sensor data generator. So that data temperature will be generated randomly. So here is I'm just starting some sample Java application. I'm opening a server socket and I'm going to generate some random temperature. And all this data will be written to that data output stream. And who is going to consume this data? The missing piece. And the missing piece is Spark. So we decided to use Spark here and Spark streaming module in particular. So here as we have Spark configuration, we are defining some settings. We are creating Ignite context. That's actually how you instruct Spark to connect to Ignite. You just need to provide Spark with Ignite configuration, and Spark connects as a client application to Ignite. Once connected, we are creating Spark RDDs. Here is we are using RDDs, but nothing prevents us from using data frames. And RDD will be like, it will be just, as a like you can see an RDD here is as a wrapper on top of Ignite cache. So here is we have Ignite cache deployed, and we are going to use RDD APIs to manipulate data stored there, to update the data stored in the caches, etc. After that, once we start this Spark application, we are going to preload some details about the sensors. The sensors are also generated, and the sensors will be deployed within United States continental boundaries. So like we are going to distribute the sensors randomly. And after that, we are going to the second method. Here is we are connecting to our streaming application. So where that application that is going to send us random temperature for sensors, we are going to do some pre-processing, such as we are going to, here is we are going to retrieve sensor ID and temperature, and after that we are going to save this to temperature RDD. And this will, as we know, temperature RDD is just a wrapper on top of Ignite cache, and this data will be streamed to Ignite eventually. And also in the background, we are going to run some analytical queries. So for instance, here is we are going to do join between, no, here is we are not doing join, we are just going to retrieve sensors IDs with the temperature between 70 and 100 degrees Fahrenheit. So we are going to do this endlessly in background from our application. So let's start this Spark application. All right, it's being booted up. All right, Spark streamer is up and running, and Spark RDDs are instantiated. So by some reason, we couldn't connect to the sensor data generator. And I know why, because that application is not running. So there is, Spark doesn't receive any data. Let's start our application. So, all right, so Spark and this application could interconnect. And now this, okay, this exception disappeared. So which means that Spark now receives all those temperature updates from our sample application. In real life, that will be your, some IoT solution that gets data from the sensors and pushes all that information back to your Spark cluster. And here, as we can see, all this data being generated and updated in real time. The temperature, and the sensor ID, and the temperature. Here is we are trying to get sensor ID. So what's the query? Strange query. Let me see. So here is we're trying to find out how many times we've got temperature reported for between 1700 for a particular sensor. Yeah, it will always return 1. Yeah, looks like we need to update this use case. But anyway, I have another good example. Here is, first of all, we will see that the data is being updated constantly. We are receiving more and more temperature updates to Ignite cluster. That's what you can see. Some CPU usage metrics. Our cluster is underutilized, so there is a lot of capacity. But now let's run some queries from here. We can do this from the application, and we can do it from here. So what's the maximum temperature reported? So we can do some refresh rate. Let's do it every second. All right, 109 degrees Fahrenheit so far. And here's another example. That's like we want to see what is the highest temperature reported in the United States. And we need to join the data. So we are considering only the sensors that are deployed within these geographical coordinates. And then we are going to sort this data by sensor ID and temperature, group by sensor ID and sort by temperature. So let's run this join. And we also can repeat this query in real time. All right, so that's like maximum temperature reported so far, and our sensor ID. That's like what we are doing in real time. So that's like another example, like something that you can create within a day. All those templates are available for download. So just go ahead and find them on GitHub. And that's like a good example how Ignite and Spark can be utilized together. So all the data is stored on Ignite. When you execute these queries from Spark, that's like actually Ignite query. So it will be executed using Ignite capabilities. No data is for sure moved from Ignite to Spark, only a final result set. If we had used data frames APIs, where you use, let's say, data frame SQL, then that SQL will be analyzed, and Ignite would ensure that most of it is executed in place on Ignite, so that we also don't need to move any data from Ignite to Spark. All right, so that was Spark and Ignite, and final piece that is left for our today conversation is Kafka, because like Kafka is one of the dominant projects in the market that is utilized for streaming use cases. And just today, I wanted just to spend time, talking about what's available in GridGain. For those of you who don't know, GridGain is an enterprise vendor who supports Ignite for mission-critical deployments. And also, GridGain is built on top of Ignite, and it goes with enterprise features needed for mission-critical applications such as data center application, advanced security management and monitoring. And one of those features is GridGain Kafka integration, which is certified by Confluent. And on this diagram, actually, we can see how Ignite or GridGain can be used together with Kafka. The idea is pretty simple. So you can use Ignite as a source for your Kafka connector or as a sink. And usually if you use it as a source, in this case, Ignite, GridGain, Kafka, Ignite, we are going to push changes or different updates to your Kafka topics. And then you decide what to do with them. However, in most of the scenarios, we see that Ignite is used as a sink, like your final destination, your storage that is being used for streaming analytics while once the data is got there. And here is Kafka. The benefit of Kafka here is that Kafka doesn't just stream the data. Kafka is fault tolerant, meaning that if you don't want to lose any single update, then Kafka, and if your application failed, then you can stream the data from the latest successful update. And that's actually what's good about this integration. For instance, you've been streamed some important information through Kafka into the Ignite cluster, and then your whole solution went down. Your application just stopped working. You restart your applications, fix the problem, and then you can continue the streaming from your latest update, so that you don't miss any piece of information. That's something that definitely stands out Kafka and Ignite integration from other streaming technology integrations. And also, like those of you who use Ignite Kafka integration, here are some differences between GridGain connector integration and Ignite Kafka integration. First of all, GridGain comes with advanced parallelism. So in general, so when we stream data in Ignite, if you don't want to go deep into the internals, usually you create one streamer per Kafka topic, and then it's hard, to scale that same streamer to the other topics. You need to start another streamer, and etc. etc. In GridGain, you just tell which caches or which topics you'd like to observe or update, and that's it. It's going to do this in parallel. Also, what's available in GridGain connector, like it's exactly once processing semantics. If Ignite Kafka, if you use Ignite open source integration together with Kafka, then let's say if Kafka fails or Ignite fails, you will not be able to proceed from the latest successful update. You need to probably disregard all the changes that came to your Kafka topics after Ignite failed, or you need to restart your streaming from scratch. In GridGain, if exactly once processing semantics are needed, you can start from the latest update. So that's configurable. And also there are some other interesting features available in the GridGain integration, such as you can filter data on the source or sync side. You can start, you can have just single connector build multiple caches and topics, etc., etc. Overall, so if you decide to use, let's say, if you think, what should I use? Like GridGain is enterprise. GridGain and Confluent integration is enterprise ready. So it's supported by GridGain for mission critical applications and for streaming analytics applications. And it's certified by Confluent, which means that Confluent guarantees that GridGain integration passed all the tests and ready to be used for your production deployments. All right, that's all. And if to summarize, I hope that you could grasp what are the benefits of in-memory computing for streaming use cases, and how streaming analytics is different from the streaming ingestion and processing, which was the beginning of the real-time streaming industry. And speaking about like technologies, we still believe that there is no silver bullet specifically for streaming use cases. Usually you combine and mix several technologies together. You have some streaming focused products. You have in-memory computing solutions or databases that can be used with those streaming technologies. And throughout this demonstration, we show how, for instance, we can take open source projects that belong to Apache Software Foundation, how we can mix them together and apply for real world business use cases, such as the trading applications that we were describing in the very beginning, or for the IoT use cases. And as you see, like throughout this conversation, we've showed how to use Apache Spark, Apache Ignite, Apache Kafka. You can use Apache Storm, etc. Everything is available in open source, which means that you can start paying nothing and you can build your architecture free of charge. But then, like, if your application is mission critical, or you need to have some enterprise support, usually every enterprise or every open source project is supported by an enterprise vendor. And here is like, if you talk about Spark, that would be Databricks. For Kafka, we have Confluent. For Ignite, we have GridGain. So start building your next generation streaming analytics application. And if you need any support, you know which door you need to knock. All right. Any questions, guys? We have 10 minutes, right? Or even more.
Yep. Okay, so if you have questions for Dennis, go ahead and enter them in the questions field within the GoToWebinar control panel. So Dennis, there is a question, and I apologize if you addressed the answer to this, but I think I'm going to ask it anyhow. And it is, do you have something like persisted Kafka streams that can be queried with DSQL in MapR?
Mm-hmm. So I think that like what we are doing with Kafka, we just integrated with Kafka in such a way that when you did some pre-processing there, then for instance, if you use Ignite as a sink, right, then Ignite can, you know, use Kafka offsets to retrieve data from Kafka from specific position. That's what available in this Confluent integration. So, but if we just talk about Kafka and MapR, most likely like MapR, if I'm not mistaken, should be working with Kafka directly, right? Then if anything is updated in Kafka, if you just need to use Kafka APIs, GridGain or Ignite for sure can, you know, retrieve data from Kafka from a certain offset or position. So that's possible to configure, to my knowledge. If you are more interested about GridGain or Ignite persistence capabilities, then at the very beginning of this topic, I've just briefly mentioned our GridGain database, GridGain memory-centric storage. And in addition to RAM, you can persist all the data to disk in Ignite or GridGain. And for instance, you can use our native persistence, which is also distributed, transactional, fully consistent or eventually consistent depending on your needs, or etc. Hope that I answered your question.
He did put a follow-up in there, and that is, it says, Kafka has lookbacks over past period of time, but in MapR, the entire stream is persisted and can be queried after the fact.
All right. Yeah. So like in Ignite, I think, yeah. So in Ignite, you can actually do the same as what you do with MapR. So once Kafka pushes data to Ignite, you can store it in Ignite for as long as you like, depending on your expiration or eviction policies. And that data can be queried from Ignite for as long as you like. Then if you no longer need this data or the data becomes stale, it can be removed from Ignite automatically, again, based on your expiration or eviction policies, or manually using your applications. Yeah, if I still don't answer your question completely, just send us a message to Ignite user list, and we'll address it there.
He says he understands, and he says thank you. So good job. All right, are there any other questions for Dennis? Going once, going twice. All right, Dennis, I guess you did a really thorough job. I want to thank you for taking the time to do the webinar today, and audience also for attending. Please make sure to go back to gridgain.com frequently. We'll be updating the webinar schedule for October, and it will be pretty meaty. So we hope that you come back and visit us, and I hope that everyone has a really great rest of their days. Dennis, thank you so much again. Thanks
to everyone for attending, and hope to see you on the line soon during our next webinars. Bye-bye.